this is the next point, that is dipole moment. Just we have seen here that if we have taken AB molecules, in case of AB molecules there are two poles. If we have taken dipole, di means two, poles means two terminals. If we have taken ionic compounds, in case of the ionic compounds we have seen as NaCl. Here Na plus Cl minus. This Na plus is one pole, this second Cl minus is second poles. Now these ideas can be taken to explain, that is in the form of the dipole moments. If we have taken dipole moments, two poles are present in case of the ionic compounds. One is positive, second will be negative. And totally how the dipole moment can be explained in case of mathematical equations. This idea can be taken in case of, you can say, AB molecule. In case of AB molecule, what happens? This A atom again B atom. The electronegativities of the two atoms can be taken. Suppose you have taken, that is D minus, delta plus. These are the charges of the two ions. They can be indicated by Q signs. The charges can be indicated as Q. Again, the distance between the two atoms can be taken. The distance between A and B atom can be taken, and it is called as the bond length. Bond length is most important. To explain the bond length, the distance from A to B can be taken. It is called as the bond length, bond distance. This idea can be taken. And again, the charges can be considered. And when we have taken as the dipole moments as concerned to the, you can say, ionic bond containing molecules, this idea can be explained as a how the dipole moment can be calculated. The dipole moment can be calculated. It can be defined as, it is a mathematical equation which is called as mu equal to Q into L. Now here Q is nothing but the charges of the two atoms can be taken. Again you can say here, that is L is nothing but distance, which is called as the bond distance. This bond distance can be taken as concerned to the two molecules can be taken, and therefore Q into L, this is the product which is called as the mu, and this mu is nothing but the dipole moment value. Dipole moment value is called as the mu. Q are the charges, again L is the bond length. When we have taken as the product, that time it is called as the dipole moment value as concerned to the molecules. If we have taken as a dipole moment values, when the dipole moment value is very higher, that time these molecules are called as the highly polar natures. High dipole moment values generally polar nature can be taken. Suppose we have taken as a water molecules. Now this water possesses H plus OH minus. These are the two poles, and these two poles can be explained as H plus and OH minus. You should take the distance, again charges. That time this molecule can be possesses, water possesses high dipole moment values. When we have taken as the product can be increases, generally what happens here, the magnitude of dipole moment value can be increases. When the dipole moment value will be higher, that time these are called as the highly ionic compounds, highly polar compounds. And therefore what happens here, if we have taken the example of the waters, that time it possesses high solvation powers. High solvation power depends upon the high dielectric constant of the waters, and therefore dipole moment values plays very important role as concerned to any molecules. And in case of the ionic compounds, this can be explained in the form of dipole moments. Dipole moment as concerned to AB molecules, how it can be calculated. Suppose A and B, both the atoms having the charges Q, here delta minus delta plus can be taken. Again this delta, now generally this A atom possesses high electronegativity as compared to B atoms, and therefore generally what happens here, they will be combined together due to presence of the positive and negative charges having electrostatic force of attraction, and bonding can be takes place very easily. If we know the charges of these atoms, if we know the bond distance of the two atoms, then dipole moment value can be calculated for such molecule, that is mu equal to Q into L. Here Q is nothing but charges, L is the bond length, mu is the dipole moment value. I have given the example as concerned to NaCl, Na plus Cl minus 2 poles, one is positive, second will be negative. Both poles can be attracted to each others by the strong electrostatic force of attraction, and hence there will be the Coulombic force is present, strong ionic bond is present, and generally this high dipole moment value possesses, if we have taken as a water, dipole moment will be higher, dielectric constant is also higher, and therefore it possesses high solvation energy. If we have taken any solute, it can be added in the water, it can be dropped in the water, that time the solvation energy of water will be higher, the solute particles can be dissolved in the water, formation of solution can be occurs. In this way, the dipole moment value of any molecule can be explained with the mathematical equation where mu equal to Q into L. This is called as the dipole moment value is mu, Q are the charges, L is the bond length. Now next point we will see on the next lecture.